This video is on solving a system of linear equations using substitution. There are two ways to solve systems of linear equations algebraically. One is using substitution, and the other is using elimination. And it's really up to you which one you want to choose. You'll learn both of these this semester, and there really are situations in which it's better to use substitution or easier to use substitution, and some in which case it's easier to use elimination. So this problem, the specific instructions are to use substitution to solve the system. And again, if you recall, when you're solving the system, you're looking for that ordered pair that works in both of the equations. And remember, sometimes you may get no solution, and sometimes you may get infinitely many solutions. But this one's specifically asking you to use substitution. But let's look at it, and suppose it just asked you simply to solve the system. In this case, when you look at a problem like this, you should see that it would be easiest to use substitution. And as we do a few examples, you'll understand why. But in this case, you're already solved. This equation right here is already solved for x. So it's telling you what x is equal to. So if you're given a system in which you already know what one of your variables is equal to in terms of an algebraic expression, or it's already solved for one of the variables here, then substitution is the easier process to use. Now, of course, that's going to become a personal choice as to whether you use substitution or elimination. But in this case, like I said, because it's already solved for one variable, substitution's will probably be the best way. Now, the instructions also say to use substitution, so we will do that. So here we already know this equation right here is already solved for x. So we know that x is equal to all of this. So what we're going to do is we're going to take this and we're going to replace x with that. So we're going to say, let's let -3, and instead of x, we're going to write 3y minus 5, and I'm always going to put this in parentheses so we remember to distribute, plus 2y equals to 8. And now I'm going to clean this up, because see, what we did was we went from having two different variables, to having the same variables. So now we can simplify this left-hand side, so we're going to get a -9y plus 15 plus 2y equals to 8. And now we just have a linear equation we're solving. -9y plus 2y, they're on the same side, so we're just simplifying, combining like terms, equals to 8. And then we're going to solve for y, so I'm going to subtract 15 from both sides. And I'm going to get -7y is -7. Divide both sides by -7. And y is 1. Now, remember, we're solving a system of linear equations, so we're looking for the ordered pair that works for both equations. So we know that y is 1, so now we have to solve for x. And you can substitute this into either equation, because remember, you're looking for a problem that, or excuse me, an ordered pair that works in both equations. So I'm going to go back in here, and since we're solving for x, I'm going to substitute what I found for y. So I'm putting this in here. And that's going to give me x equals to 3 minus 5, or x is -2. So that tells me that the ordered pair -2, 1 is the solution to this system of linear equations. Now, you can always check your answer. So I'm going to go back in and I'm going to substitute in this first equation. -2, is this equal to 3 times 1 minus 5. So -2 is equal to 3 minus 5, which is -2. So it works for the first equation, and this is similar to what we did in a previous video where you're just being asked which points are solutions to the equation system. So now we're going to go into the second one. So this is -3 times x, and we said x is -2 plus 2 times y, and y is 1, and we want to know, does this equal to 8? So -3 times -2 is 6, 2 times 1 is 2. Does it equal to 8? And it does. So we can feel pretty good that that is the correct answer. Actually, you know that it's the correct answer because that ordered pair works for both equations. So we use substitution here because the instructions tell us to use substitution. And hopefully you'll begin to recognize that substitution is going to be the easier method if you can see that one of the variables is already solved for. Okay, so this one is our second system of linear equations using substitution, or second example. And in this problem, it's not quite as straightforward as the previous problem, where we had actually already solved, or it was one of the equations was already solved for a variable. But if you see here, the y does not have a coefficient, or excuse me, its coefficient is 1. So it would be very easy to solve for y here without getting any fractions. So that's another time when substitution is a good one to use, a good method to use. So what we're going to do here is we're going to solve for y. And you can use elimination for this problem. It's specifically asking us to use substitution, but once you get used to the two processes, you'll begin to get a little bit more comfortable deciding which one you want to use. Alright, so I'm going to add 2x to both sides, and I'm going to get y equals to 2x minus 4. So now we know y is 2x minus 4. So I can go back into this first equation. Don't substitute it back into the equation you started with, because then it would just, everything is going to cancel out. But we can go back into that first equation and substitute it in for y. So I've got 3x plus 4 times 2x minus 4 equals negative 5. So you can see what's happening here is we're by using substitution, we now have a linear equation with just one variable, which we know how to solve. So that's going to be plus 8x minus 16 equals to negative 5. And just solve this. Then solve this the same way you would solve any linear equation. 3x plus 8x is 11x minus 16. It's negative 5. I'm going to add 16 to both sides. And I get 11x is 11. Divide by 11, and x is 1. Now remember, your goal here is to find that ordered pair that works in both of these equations, because it's going to represent the point where these two lines intersect. So we know that x is 1, so we can substitute that 1 back into either of these equations. And I'm just going to substitute it back into the first equation. So we're going to take this x equals 1 and substitute it in. 3 times 1 plus 4y equals negative 5. It's going to give me 3 plus 4y is negative 5. Subtract 3 from both sides, we get y equals to negative 8. And divide by 4, and y is negative 2. So that gives me the ordered pair 1, negative 2. So we can always check ourselves. So we'll come back over here to check. So I'm going to check in the first equation, so that's going to give me 3 times 1 plus 4 times negative 2, and we want to know, does that equal to negative 5? 3 times 1 is 3 minus 8. Is that negative 5? It is indeed. So far so good. Let's substitute it into the second equation, so that's going to be negative 2 times 1 plus negative 2, and the question is, does that give us negative 4? Negative 2 times 1 is negative 2. Negative 2 plus negative 2 is indeed negative 4. So this is the solution to the system of equations, because this is the point that works in both of these equations. It'll be the intersection, the point of intersection of the two lines that we would get if we were to draw these, graph these two equations.